Alright, this video is going to be on two important theorems in calculus. The first one is Rolle's theorem. Officially, it says let f of x be continuous on the interval a to b so that f of a equals f of b. There must be some c value between a and b where f prime of c equals 0. Basically, it says there must be some min or max in between. All right. The common statement, what goes up must come down. All right. So let's, quick example of this. Say here you have a quarterback. All right. I know I didn't have a football helmet on. Say he is f of a. All right. So this is a. And somewhere downfield, we have his receiver. B. So this is f of b. Right? When he throws the football, it's going to go up and come down, and the receiver's going to catch it. Let me draw a football. All right, that's a pretty bad looking football. All right. Somewhere in between the quarterback and the receiver, f of c, f prime of c, because remember, the derivative is the slope of the tangent line. So somewhere in here, the slope of the tangent line is going to be 0. All right, that's what Rolle's theorem tells you. It's somewhere between f of a and f of b. You're going to have your line is going to have your tangent line is going to have a slope of 0. Somewhere in between these 2 points. All right. What that would look like graphically. All right, let me draw coordinate plane. So if this is A and this is B, regardless if you go this way or this way, oops, I missed. That was supposed to go through here. All right, regardless which way you go, somewhere you're going to have f of c equaling 0. All right, so there must be a min or max somewhere in between A and B, is what Rolle's theorem says. That's all it says. All right. The second theorem is the mean value theorem for derivatives. So, same circumstance, let f of x be continuous on the interval a to b. There must be some x value c between a and b so that f prime of c equals f of b minus f of a over b minus a. All right. Sounds complicated in theorem form. Let me show you what it looks like in graphic form. Say your house is here. All right, and here you are standing in your house. So your buddy's house is up here. And say it's uphill. All right, if you walk straight to his house, all right, if you walk straight to his house, you're walking uphill, so that's the slope. All right, this is A, this is B. Now, what the mean value theorem says is no matter what path you take, all right, no matter what path you take, you could even do a path like this. All right, but no matter what path you take, somewhere along there, the slope is going to be the same as this slope here. All right, it doesn't matter which path you take. Oops, somewhere between A and B, your f prime of c is going to equal the same thing as if you had taken a straight shot. All right, on all of these. Okay, and then this one's going to have multiples because you can have that one there, you can have that one there, this one here. All right. Now, an example of what this can be used for. All right, because this might be a little confusing to you. Say you had a road. Let's draw a road. It's going to be a pretty terrible road and vehicle. Why? Because I can't really draw on this thing very well. All right, so here's our road. And here we have a car. It's going to be a terrible car. All right, so there we have a car. And then I'm going to copy it because I'm going to put the car down. Away a little bit. Clone. Apparently I didn't get the wheels. All right, so here we have our two cars. It's actually the same car. You'll see what I mean. All right, say we have a police officer here. And he has a radar gun. Yep, that's my radar gun. And he clocks the car doing 55 miles an hour. All right. And then say there's a cop down here, and he radars the same car doing 50 miles per hour. All right. If he gets to this cop only 4 minutes later, all right, and they are 5 miles apart. All right. They are 5 miles apart. Can we prove that he exceeded the speed limit of 55 miles an hour? Right? Because when this car, if the speed limit's 55, this cop radared him and he's doing 55, he's not speeding. 4 minutes later, this cop radared him, he's doing 50, so he's still not speeding. But can we prove that he was speeding somewhere in the middle? All right. Yes, we can, because we can use average speed. And this is where the mean value theorem comes in. We know that distance equals rate times time. All right. So our distance was 5 miles. We don't know our rate. We know our time was 4 minutes. All right. Divide both sides by 4 minutes because we want to get the rate by itself. All right. So we know that his rate was 1.25 miles per minute. All right. Now, if we take that and multiply it by 60 miles an hour, okay, because at 60, there's 60 minutes in an hour, so let's multiply that by 60 miles in 1 hour. Our rate comes out to be 75 miles per hour. All right, so therefore, he would have to average 75 miles an hour between the two cops in order to be able to get to the second one 4 minutes later. Therefore, we just proved that at some point, well, pretty much every point between here, he exceeded the 55 mile an hour speed limit. All right. So that is what the mean value theorem can help you do. It can help you get the average speed between 2 points. All right. Of course, there's other uses for it. This is one of the big ones that you can use it for. All right. To prove that cars are speeding. All right. So those are your two important theorems: the mean value theorem and Rolle's theorem. All right. Quick review of Rolle's theorem. Basically, what goes up must come down, and there's got to be a max or a min in there somewhere. All right. Somewhere between the two, there's going to be a max or a min, and your slope of your tangent line is going to be 0. All right. So that's your Rolle's theorem and your mean value theorem. All right. See you tomorrow in class.